Okay, question 11 on set 20 is extras for experts. I've got to warn you, this is the level at which you'll be tested at mostly. The earlier parts of set 20 really are just warm up. So I love this reaction. This is where lithium metal reacts with water to produce lithium and the hydroxide ion and hydrogen gas. When you do this by scraping the lithium out of an unnamed lithium battery, hypothetically, and dropping it in some water, you find you get a beautiful pink flame. I caution you not to try this at home because lithium salts are actually toxic, unlike sodium and potassium salts, and should be left alone. But at any rate, I tell you because this is chemistry, and well, chemistry's fun, and that's where you see it in the chemistry. Okay, enough of this malarkey. Let's get back to balancing. First thing we need to do is split it into its redox reactions, its oxidation and its reduction. Well, we can see from this quite clearly that our lithium metal is going to be converted to lithium plus 1. That's a pretty straightforward thing to do. You can see that one standing a mile away, and in so doing that, what it will do is it will produce for itself an electron, which we are just about to grab there. Hang on, plus electron. Oh, I see what's happened. I'm stuck in my underline. Okay, never mind. Please forgive me. I'm going to get rid of that one. Okay. So, what happens on the oxidation is quite an interesting thing, however. When on the reduction is quite an interesting thing. This side is the oxidation. On the reduction, we've got the hydrogens in water, okay? And they are going to be converted through to hydroxide ions, in which there's not much change, and H2, which is the gas. This is the thing which makes the whole thing go boom. Okay, let's have a quick look at what's happening there. So you can see that oxygen is not really going to change its oxidation number. It's nearly always -2 unless there's a peroxide involved, which is not the case here, or an elemental oxygen, which is not the case here either. So this is not going to be oxidized, -2 to -2. This hydrogen, which is sitting at +1 state, is also not going to be oxidized over here. This hydrogen's just going to find its way straight over there, as that it's +1 over here and it's +1 over here. +1 plus -2 leaves us, of course, with our overall charge of -1. So we can see that there's no change in the redox of those things. But something interesting happens with the hydrogen. Here's what's happened to the hydrogen. This hydrogen here is at +1 and it's going over to 0. So if you go from +1 through to 0, you've got to add an electron to it, don't you? So we're going to have some electrons added, but we don't quite know yet. But we're getting ahead of ourselves a little bit because what we have to do is we've got to balance the atoms in the ion equation. So let's do that. In the half redox equation. So we've got H2O, we've got 2 H's and 3 over here. What we need to do is we need to multiply 2 waters and make 2 hydroxides. Okay, in that sort of situation, 4 goes to 2 and 2, that's atom balanced. Now, we said we had to add electrons on this side. If we've got 4 of those and 2 are going across from +1 to 0, then we're going to need 2 electrons. And there you have it. That's nicely balanced redox equation. Now we can look at our 2 half equations and deal with them. This produces 1 electron, this consumes 2. What do we need to do to this half reaction to scale it so that it will produce the 2 necessary? Well, I guess you've seen this before. We multiply it by 2. So overall our reaction becomes lithium, but 2 of them because we scaled it, plus, plus 2 waters, just go that one down, are going to make for us 2 hydroxides and hydrogen. And where did that darn lithium go? It went over here. Oh, let me lose my subscript. There you go, lithium. But remember, we said we multiplied by 2. We had to scale by 2, so we've got to also scale across there. And this there is then your balanced redox equation for this slightly more complicated example, which involved the reduction of water. What you can see there is that 2 lithiums, all the atoms are balanced and all the charges balanced, and that is your answer. I hope that helps.